Friends, welcome back to my channel. So today I have come back with the qPCR data that I showed you last time about how to do a ΔΔCT value analysis with these data for gene expression purpose. But today, as I said before, there are multiple methods actually to analyze this qPCR data for gene expression. So besides ΔΔCT values, there is another method which is called Pfaffl method. So this method is also useful for some of the qPCR data analysis where the PCR efficiency seems to be really very good and very close to the target and the reference genes. So as similar, today I'll show you the qPCR data analysis with GAPDH as a reference gene and Pilau as a target gene. So as you can see, I have different conditions. So one is BHI, which is the control, and another is WT, which is the target, the wild type for my analysis. And all right, so I'm Dr. Shah. I welcome you again to my channel. So let's start. All right, so I know the mean PCR efficiency for these samples. So I have the average for these reference gene is 1.979, which is close to 2, and I have the average mean PCR efficiency for my target gene is 1.984, which is very, very similar to the reference gene. So if this is the case, then probably can think of using Pfaffl method for your data analysis. All right, for these, I have to find out the average CQ of the control here, so BHI, so for both reference and target genes. So let's calculate. I will make an average of these 6. All right, I got the average for GAPDH reference, BHI CQ, and now I will find out the average for my target gene. So there is some thing here. I'll just select individually. It seems to be, you have to select like that. Yes. All right, so this seems to be the average. Pretty good here. And now I got the average value. So I have to now find out the difference in the CT values from untreated to treated. This is the untreated for everything. So I'll just write it here. 11.035 minus this. Okay, so I got this. The same thing I will do for every cell here. Just to make my analysis a bit quicker. All right, so the same thing applies here as well. So I'll calculate. So 32.530 minus these. Okay, so just to make my analysis a bit quicker, I will delete these things. It's not needed. All right, so I got the difference in the CT values. Now, as you can see in the sign, I have to calculate the mean PCR efficiency to the power this CT subtraction. So how can I do this? I will make this PCR efficiency here to the power these one. Okay, so I got this. So the similar way I will do, just I will, there's no any value there, so this way it's all 1. All right, so the same thing I'll do here as well for my target gene. It should be this one to the power this. All right, I'll do the same thing. As there's no any power for that, it will be 1. Okay, so now I will calculate the fold change here. This fold change applies for the target gene compared to the reference one. So I have to use these one. So what it says, the efficiency values, that means these one of target untreated. So these values divided by efficiency values of treated untreated reference gene. So that means I have to divide the target values by the reference values here in G. Okay, so how can I do this? Equals these target divided by these VHI. So we have to actually align between these two different groups. Okay, I will as do the same, so it will also be the same thing. As there's no any data there, it's all going to be infinitive or not calculated. All right, so as you can see, we got the fold change, so from BHI to wild type in my target gene. So this is close to 1, same as this, close to 1. And for my target wild type gene expression is 60 or 65. So as similarly, now I can plot this data. Okay, so you'll just have to write BHI1, BHI2, 1, plot 2. So just enter the data 0.7, 1.5, 60.3, and 65. All right. So these data now you can easily plot, as you already have seen my previous video, but I'll just quickly go through this process in case if you have missed my previous video. So I'll go insert and then select a plot, probably this one, and this data chart will directly come. So this is my control, this is my target gene. So you can just quickly change the title of this plot. So I'll just write plot gene expression. You can also edit different individual plots, names and everything, and also these values, but I'll just show you in my next video. Probably it helped you analyzing your data, and if you have any questions or suggestions or opinion, whatever, just give me a short or just comment in the video, whatever actually ways you prefer. And thank you so much for enjoying this video, and please subscribe to my channel and share it to your fellows if you think that this video will be useful for them as well. And I will see you next time. Thanks a lot. Bye.